Okay, so the title of my talk is, Can Logic Make Us More Rational? Let's see how we can understand this question. First of all, I would like to remember the origin of logic. I am quite interested in the history of logic, and I think it's good to know a few things about that. So, in Greek, we have this word logos, and as we know, logic comes from logos, and this is the word that we are using in English, French, German, Portuguese, and so on. And the word logos in Greek has four important meanings that you can see here. It's science, reasoning, language, and relation. Relation is not necessarily sometimes people don't know exactly why relation, what does it mean. We will try to talk about that. So let me give you a quotation by Rougier. It's in French, but his book is not translated in English, but I tried to make a translation about what to say about logos. The logos is a creation of the Greek genius in the science, arts, moral, and politics. And the logos mean at the same time discourse, reasoning, relation, and proportion. So I think it's very important to have this in mind when we are talking about logic and rationality, because as you can see here, reasoning appear, rationality appear in various ways here through science, relation, ratio, and logic, of course. I would like to explain this difference. So it's a difference which is very important that I've been developing since a couple of years. Difference between two meanings of logic. Okay. I make a kind of joke because I will use two different words with only a slight change. Logic with a small L and logic with a big L. I will explain to you why it's a good way to make the difference in the linguistic way. Okay. So logic with a capital L. By logic with a capital L, I mean here reasoning, in a very wide sense of the word. Reasoning. And then logic with a small L is a theory of reasoning. It is very important to make this distinction. And by the theory of reasoning, inside this theory of reasoning, this theory of reasoning can take many different shapes. But we can make a description of this theory of reasoning talking about, for example, systems of logic. So we have a lot of different systems of logic. At the beginning, the system of Aristotle, syllogistics, and now in modern logic, first order classical logic, and a lot of non-classical logic, fuzzy logic, par constant logic. I have been working on par constant logic especially, so I will talk about that. So we have to keep in mind this distinction. Okay. Let's see, discussion was famous at some point in Berkeley, California. You know, you have these two guys, William Kahan and Lotfi Zadeh. And so Lotfi Zadeh is very famous as a promoter of fuzzy logic. And on the other side, you have computer scientist William Kahan. You see his picture here. And when Zadeh started to develop fuzzy logic, and it was quite a success, Kahan was a bit irritated by that, and he wrote the following to Zadeh. It's a personal letter, which is quite famous, saying that fuzzy is something wrong. Okay. What we need is more logical thinking, not less, and so on. So if we want to understand this discussion, it's good to understand it from this point of view of the distinction between theory of reasoning and reasoning itself. Let me try to explain that. For example, from the point of view of fuzzy logic, what Kahan wants to say? He say, for him, I try to summarize his position, logic formulating using this distinction between logic with a big L and logic with a small L. So logic should not be fuzzy. So you see there is kind of normative approach here. So reasoning itself should not be fuzzy. Therefore, logic with a small L, I mean, system of logic, theory of logic, should not be fuzzy, because we want to develop reasoning which is not fuzzy. And we have no reason, when developing this kind of theory of reasoning, to use a fuzzy logic as a system of logic. On the other hand, what is exactly the position of Zadeh? It's not completely clear, but we can say, well, for him, logic is fuzzy. Reasoning is fuzzy, and maybe reality is fuzzy. And for this reason, and for him this is not bad, and for this reason, we should develop fuzzy logic. We should have a theory of reasoning which is a fuzzy logic system. This is the way that we can understand this discussion. Now another question about relation between the theory of reasoning, system of logic. Nowadays, since many years, what people learn at school, I mean at university, in philosophy department in particular, what they learn is classical propositional logic, and one of the very famous tools is the truth table. So I think everybody has heard about truth table, I've already seen a truth table, and so on. So here we have a truth table, and it's a system. A truth table is a system. It's related to a system of logic, classical propositional logic. It's a way to present classical propositional logic. Now, if we want to use the word truth, I will not speak too much about truth today, but it's also very important, truth and reasoning. So can we say that truth table is useful to reach the truth? No. And there was a lot of discussion at the beginning of the 20th century about that. And here also, again, we have this distinction between system and reach the truth. It's reasoning in the way that we are going from truth to truth. Okay, now let me give interesting quotation by a famous philosopher to see in which sense they understand logic, if they are making this distinction between reasoning and theory of reasoning, you will see. So you see here I wrote logic with a lambda. It's like a variable. It can be big L, it can be small l. So logic as conceived by great thinkers, sometimes it's more reasoning, sometimes it's more theory of reasoning, as you will see. Sometimes it's quite ambiguous. So there is this very famous quotation by Locke: logic is anatomy of thought. Of course, here I put capital L because it's the first word of the sentence. But when Locke says that, what does it mean? Is he talking about reasoning or about theory of reasoning? It's not clear in the sense that anatomy itself is not something which has a clear meaning. But now there is this very famous quotation from the preface of the second edition of the Critique of Pure Reason by Kant. Well, and he says that logic has advanced in this sure course even from the earliest time is apparent from the fact that since Aristotle it has been unable to advance a step, and thus to all appearance has reached its completion. Well, of course, it's clear that here Kant is talking about logic with a small l. He's talking about the theory of reason, not reasoning itself. Now let's see Boole, which can be considered in many ways as the founder of modern logic. In his book famous book, Law of Thought, he wrote the following: the design of the following treatise is to investigate the fundamental laws of those operations of the mind by which reasoning is performed, to give expression to them in the symbolic language of a calculus, and upon this foundation to establish the science of logic. So when Boole is talking here about the science of logic, he's talking about the science of reasoning. So in some sense, he's making the distinction because he's saying, well, we are talking about the science of logic. Science of logic, science of reasoning. Now, there is a quotation by Solis Carroll, as maybe people know, was a logician. He wrote several books about logic, symbolic logic. And there is this quotation by his book, Alice in Wonderland. In this quotation by Lewis Carroll, Quine chose to put this quotation at the beginning of his book, Philosophy of Logic, which is a very famous book, Philosophy of Logic. Well, we can wonder why Quine decided to choose this sentence. I don't think, we don't know, maybe it's just because it's Lewis Carroll or something like that. But if we read this sentence by Lewis Carroll, well, that's logic. Contrary to as so, it might be, and if it were so, it should be. As it isn't, it ain't. That's logic. Well, it seems that here Lewis Carroll is describing a kind of way of reasoning. So he's not talking about logic as a theory of reasoning. He's talking about reasoning itself. Okay. And I think Quine was aware of that. Yeah. But maybe Quine liked this sentence because it seems that it's a kind of classical reasoning, and so classical logic is the same as reasoning. We can interpret this in this way. I mean. Now, more quotation, one by Peirce also, which is a very famous man in the development of modern logic. And it's an interesting quotation where they say bad reasoning as well as good reasoning is possible. And this fact is the foundation of the practical side of logic. So here we have practical side of logic is talking about logic as a kind of normative science of reasoning, something like that. This is the way that we can interpret. Now a strange quotation by Wittgenstein, also a famous logician. This is, by the way, this photography is the house designed by Wittgenstein in Vienna. And so logic takes care of itself, and all we have to do is to look and to see how it does it. Well, in this sense, we can interpret, this may look strange, but if we understood logic as reasoning itself, that's not necessarily so problematic. Now, if we look at a quotation like this one by Saint-Exupéry, pure logic is the ruin of the spirit. Well, here, Saint-Exupéry is talking about reasoning by opposition to something more emotional or something more literature. Again, Rougier wrote the following: with the discovery of the conventional and relative character of logic, human spirit has burned its last idol. Well, when Rougier is talking about that, what is relative here? I will talk again about this later on today. Is it the reasoning itself, or is it the fear of reasoning? Well, we can understand that it's reasoning itself. Reasoning itself, there is no special laws not as a science, but as a process of human reasoning in his mind or his brain or anything like that. And the last quotation, which is interesting because it's related with logic and reality. So we know that the development of quantum physics has led to some change in logic. People have tried to develop new logic for that. And then the idea there is to develop a new logic to have a better understanding of reality. And you have this quotation by Heisenberg, where what he's saying is that maybe we have to change our logic to have a better understanding of reality. And I guess here it's not necessarily clear if he's talking about reasoning itself or the theory of reasoning, or a mix of the two. So summarizing, you see that this distinction between logic as reasoning, logic as theory of reasoning, much of the time is not clear. And I think this is important to make this distinction. Let me explain why I choose this to express this distinction with a big L and a small l. Because it's what happened in history. This is over cases. I don't know over cases, but this one is famous. So in English, also in French, people who use these two different way of writing, history with a small h and history with a big H. And history with a big H is the series of events which are studied by the science which is called history with a small h, sometimes historical science or historiography or something like that. So that's why I decide to make this to express the difference between reasoning and theory of reasoning with this small m and capital R, so it's easy to remember. Okay. Most of the time, if we look at the science and its object of study, we have a difference. We have different name for that. We say, well, biology is a science of living organism, physics, the science of matter, linguistics, the science of language, and so on. So generally, there are two different words. Okay. Of course, there is some variation because at the start, physics in Greek there was the name. There was no difference because the word physics was also the subject matter of the science of physics. Okay, so you see, here we are making a distinction. Now if you ask what is the subject matter of logic? It's not clear because, you know, people are not making this distinction. Well, someone may say logic is the study of reasoning, something like that. This is what, this is the general idea, the study of reasoning. But sometimes people use the word logic as a synonym to reasoning. What we can say is that in both cases, I will make a more comparison between these two situations. Logic is not logic, history is not history. This is clear, even we are using some words which are very similar. But one of the reasons we are using the same word is because there is a strong connection between the two. I think that's the reason. So if I ask when did history start? I'm talking here history with a big H. Well, it's not clear. There are different answers. Someone may say at the end of prehistory because people are making distinction between two stages, okay, history, prehistory. Some people may argue that history started when history started. This has been argued by different people. So the people say, well, at the time in Greece where people like Thucydide and these people were the first historians, then start really history. This is a provocative statement, but it can make sense. Well, and then we can say at the year 0, since zero is the first number, natural number, something like that. If we want to make a connection between history and numbers. Okay. Well, I'm saying this as a kind of joke because people may say, well, history starts when Jesus Christ was born. Yeah. Well, and then when did logic start? We can make a similar comparison. At the end of mythology, if you want to make a parallel between the two, so there was mythology and then starts science, you know, reasoning and things like that, if we understand logic in a very wide sense of the logos. And someone may say logic started when logic started. And this, in fact, most of the people say something like that, you know, because people say, well, logic started with Aristotle. Why? Because Aristotle was the first to make theory of reasoning. But we can ask the question, is it true that because of that, people start to reason? Maybe not. Maybe people were reasoning before. And if we want to use mathematics, we can talk about Aleph Zero, which was the new beginning of logic in the 19th century with the transfinite numbers and so on. So let's come back to Aristotle. So if you ask someone, well, you ask if Aristotle is the creator of logic, most of the people will say yes. Because of this, because I understand logic as a theory of reasoning. But on the other hand, most of the people agree that Aristotle was not the first to reason, to have a logic in this sense. Even Aristotle himself, you know, because Aristotle was one of the promoters of the definition of human beings as a rational animal, in Greek, a logical animal. So if human beings are conceived as logical animals, they were logical since the start, you know. There was no change. But this can be, we can have, using this distinction between reasoning and theory of reasoning, in fact, we can have a completely different vision about the story. Because I have been studying the history of mathematics and so on in Greece. And what we know is that at some point in the school of Pythagoras, people start to use the reduction to the absurd. And this was completely changed in mathematics. Some people say that the real beginning of mathematics is the first proof using reduction to the absurd, which is the proof that square root of 2 is not rational. So these people in mathematics, in Greek mathematics, they start to reason in a different way. So maybe we can argue, well, this was the real start of reasoning. It's not, there is no known apparent manifestation of this reduction to the absurd before this time in Greece or in another location on the Earth. So we can identify, if we identify the first use of reduction to the absurd with the beginning of mathematics, we can also say that it's a beginning of logic with a big L. And this was many years, I mean, not so many years, but years before Aristotle. And what happened in Greece is that Aristotle, when he developed syllogistic, he didn't describe the reduction to the absurd, at least not directly, very indirectly, and he was not specially interested in mathematical reasoning. This is very famous, but so this is, in some sense, this is a weak point, but the good point is that Aristotle was interested in all kinds of reasoning, so he had a very universal approach to reasoning. And he was a promoter, the main promoter of the idea that the validity of a reasoning is independent of the topic we are reasoning about. This is a very important point in the development of logic with Aristotle. So this independence between the form of the reasoning and the contents, we don't know if Aristotle was maybe the first to make a theory about that, but people in Greece were practicing this kind of valid argument where there was this independence between the form and the content. Because if we remember Plato, well, when he put this famous motto at the entrance of the academy that people should know geometry, his main idea was if people want to go on to develop their study, they know how to reason. Okay, but you can then apply this methodology of reasoning of mathematics to any kind of subject, and this is, of course, what I try to do about all the important fundamental notions of philosophy. Well, now, so the logic of Aristotle, his theory of his system of logic, syllogistic, was the main system during many centuries. People were learning this at school, but at some point, people decide to completely reject this, and most famous were Descartes and Pascal. It is very interesting to remember that, because we have here this paradox. You know, people say Descartes Cartesian, someone is very Cartesian and something like that. It means it's someone who is very rational, very logic, and so on. But Descartes was against logic with a small l, as a theory of reasoning, because his idea was that we don't need a theory, we don't really need to apply some rules to develop our reasoning. It's a very famous sentence. Le bon sens, la chose la mieux partagée du monde, means, well, we have this capacity of reasoning. Of course, we can improve it, and we give some ideas with this rule for the direction of the mind, and also in the Discordia method. But his idea is that to use syllogistic is completely wrong. And if we use syllogistic, instead of improving our reasoning, we will turn our reasoning in it will be a kind of obstacle to develop science. So here I just make a table of the 4 main precepts of methodology of Descartes that you can find in his work. It's very famous: clarity, division, assumption, exhaustivity. So that's the idea of Descartes. So it's not to make a system of logic. It's to promote good reasoning through some very general methodology. But in some sense, it's also a kind of theory. I mean, if we can say it's a kind of logic, not a system of logic, but it's a kind of theory of reasoning. Now, if we look at Pascal, which was more or less at the same time, he had some very ideas, but Pascal was more like a mathematician in general. So he will put some rules which are very close to modern mathematics. Here he has a famous quotation by Pascal. It's a bit difficult to translate in English. Je ne dispute jamais du nom pourvu qu'on m'avertisse du sens qu'on lui donne. It's a very mathematical way to think, you know, because by saying that, Pascal was criticizing people that spend all their time in the discussion to say, well, this means that, and so on. So they were too close to the language. And this, he didn't like that. And so he had a very much more general abstract idea of how to proceed. The fact that we can choose arbitrary name. And this is completely typical of modern mathematics. Hilbert promoted this. You know, he said, well, in geometry, instead of talking about line and point, you can talk about beer and wurst or something like that. I don't remember exactly the quotation, but, and he says the name is not important because we can understand, we can interpret, we have a definition, an axiom, and then we can interpret this. The meaning of the notion depends on this axiom and definition. So here we have 8 rules. They are not stated explicitly like a table like that, but it's not difficult to draw this table when you read this small book by Pascal, L'Esprit de Géométrie. And this rule has been completely adopted by modern logicians, and especially Alfred Tarski was very fond of Pascal. So he wrote a paper about that, in the 30s something. He wrote a paper about what is deduction and so on. And he repeats all these ideas, and insisting of the fact that we can go in a completely arbitrary way. Well, this is general ideas. But once again, here we don't really have a system of logic. So Pascal was also criticizing quite a lot syllogistic. He wanted to replace this system by some general rules. Now, if we look at what happened in the development of logic in Poland, we have some similar thing, because, you know, they like, the Polish people, they like to use this expression, methodology of deductive science. So they have some general, principle like this one by Pascal. But then, from that, they start to develop some more specific systems of mathematics and also of logic. Now, let's go to the beginning of modern logic with Boole. So, as we know, there is no strong opposition between Boole and traditional logic, because Boole was not against syllogistic. The difference between someone like Kant and Boole is that we can say, well, for Kant, reasoning will be always the same. And since the theory of Aristotle is a good description of this reasoning, so everything is already closed. On the other hand, Boole had the idea that reasoning will be always the same, but he wanted to give a better description of reasoning, of the theory of syllogists of Aristotle. And by doing that, he started to make a lot, even if it was not his intention to change this theory, he started to make a lot of change. Here we have a quotation by the wife of Boole, who was also a mathematician. Boole died quite young, and then his wife was going on to write some books about this general approach of George Boole, because they were working together. So it's interesting, she said, many people think that it's impossible to make algebra about anything except number. This is a complete mistake. The use of algebra is to free people from bondage. But we have to understand what kind of algebra they are talking about. This I will try to explain. So this is the change, the basic change in modern logic is the introduction, is a mathematization of logic. And this is why it's very interesting. Because mathematics is considered, since many centuries and up to now, is considered as one of the highest forms of reasoning. Okay. Now, if we want to understand reasoning, why not? We have to reason. Why not using mathematics? That was the idea of Boole. And this idea that we can generalize algebra is not only about quantity numbers, but we can apply this methodology of symbolic algebra, which was developed by Peacock and Gregory at the beginning of the 19th century. We can apply this methodology to understand what is reasoning. So there is this interesting proposition 4 in chapter 3 of the law of thought, where Boole wrote the following. It's a proposition, and he has a proof of this proposition. The principle of non-contradiction is a consequence of the fundamental law of thought, whose expression is x2 is x equal to s. x22 is equal to s to x. Now, it's very interesting because since the time of Aristotle, people were considering that principle of non-contradiction was a fundamental law of logic. We have to understand in which sense. But it's very famous. And Boole, for him, it's possible to deduce this principle of non-contradiction from what he calls here the fundamental law of thought. Now, if you ask someone why this is a fundamental law of thought, in principle, nobody will understand. Why this should be a fundamental law of thought? Very strange. Yeah. So, and if you ask someone to make this proof of this proposition, now it's not clear that people will be able to make this proof. Proof is not very difficult, it's 3 lines. But it's a question of presentation, how we can understand the principle of non-contradiction. But it's funny, this proposition 4 of Boole, because it remembers this discussion between Euler and Diderot in St. Petersburg. It's famous that Diderot went to St. Petersburg. He was invited there, and Euler, a very famous mathematician, was working in St. Petersburg. And Diderot started to talk about religion, so he was an atheist. And at some point, Euler presented this equation. He said, from this, hence God exists, and then Diderot had to come back to France because he was not able to reply. Why not? So it's funny because it's, we can make a parallel between this and Boole, because it's a connection between two things which are not necessarily clear. You know, you have a principle of non-contradiction that for many people is something more like metaphysical, ontological, and on the other hand, you have an equation. How we can establish a relation of these two things, how we can deduce one from another one. So I try to replicate the history between Boole and Marx. So as we know, Marx was in England at the time of Boole. And then we can apply this equation to a contradiction, as we know that in Marxian theory, contradiction is very important. But according to Boole, there was no contradiction. Okay. Now, let me say a few about the different terminology which was used to talk about modern logic. So I try to make a list here. Nowadays, we can talk simply about logic, but this different expression, like methodology of deductive science, was popular in Poland. Metamathematics was promoted by Hilbert, and we have symbolic algebra and formal logic, and so. It's interesting to have a look at this different expression because it shows different way to understand what is logic. As a theory, I mean, as a kind of theory, but sometimes the name is changing because of the way that the theory is manifesting. So, the expression symbolic logic, I will not talk too much about this today because it's a long story, but just to remember that symbolic logic, the expression is a derivation of symbolic algebra, and there is a special meaning of that. And then after this period of Boole, it was used in a different way by John Vane and the Association for Symbolic Logic, which is the main association of logic, a journal of symbolic logic. The name is a bit weird, but now I would like to talk more about formal logic, the meaning of formal. Because the expression formal logic was introduced by Kant. But it's strange. So it's strange to use the expression formal logic to talk about modern logic, because as we have seen, Kant were just saying, well, syllogistic is good, there will be nothing new in the future. So why using this expression formal logic to talk about something which is against Kant, I mean modern logic? There are different meanings of this expression, and the first is original, this important distinction of Aristotle. the so-called endomorphism. Well, this idea of Aristotle, I mean, it's related to all his philosophy, this endomorphism, so it's something we can say, but it's really something related with Aristotle. It's still, so there is no change. What I want to say is there is no change between this conception of formal logic at the time of Aristotle and at the time of modern logic. But now we can, there are different, the expression formal logic is used in different ways, like people, formalists, the famous formalist. This expression is used to talk about tendency in modern logic, Hilbert and so on, formalist school. So here we have, I wrote a paper about this, making the distinction between 5 meanings of formal. So it's very, so we can see that this expression is very ambiguous. Now, if we keep in mind the first point, there is no strong difference between modern logic and logic of Aristotle. What we can say, and it's very easy to understand, is that Aristotle made the distinction between the form of reasoning and the content of reasoning, and he said, well, the validity of reasoning is dependent of the content. This is still the way to think about logic nowadays as a theory of reasoning and as a way of reasoning in modern logic. But what has changed is the characterization of the form, logical form. Well, so, but there are some important distinction. Why? Because Barbara, you know, it's famous, the most famous figure of syllogistics. Everybody has heard about her. Well, Barbara. So, what is the main idea of the theory of Aristotle? I would say, in fact, that the syllogistic is not only a theory of reasoning, because since it's normative, Aristotle wants to promote a good way of reasoning. There is not really a real distinction at this point about the theory and the reality of reasoning, because we should reason like that. But the main point of syllogistic is that there is something that disappears. It's a middle term. So this is the main feature of syllogistic. You succeed to relate two notions by a third notion that disappear. So it's very interesting from the philosophical point of view, this conception of a system of logic. But in modern logic, there was something which was developed, which is connected with that, but then Barbara will disappear. Well, this logician here is not so famous, but nowadays, but he was famous at some point, Paul Hertz. He was also a physicist, but it's not the same as the famous guy from the Hertz, the most famous one, but it's quite a common name in Germany, Hertz. So, Paul Hertz, well, he developed a system of logic. He was working at Göttingen at some point. He developed a system of logic where, in the 20s, where there is a rule in the system that he decided to call cut in German. But at the same time, he was also calling this rule modus Barbara, because for him it was a kind of modern presentation of these rules of syllogistics. So Hertz himself was not against Barbara. On the contrary, he presents this system of logic, which is called that system in German, which means just system of propositions, something like that. And he decided to put some free rules, only free rules, and one of them was cut, and he called it Barbara. Unfortunately, most of the book of the writing by Hertz are not yet translated in English, but I quote the original in Erkenntnis, where I talk about that. Well, but what happened next? So Gensen was also working in the same school in Göttingen. He started to do his research by reading the paper by Hertz at the end of the 20s. He formulated the system of Hertz in a different way, but not completely different, but slightly different. This is the cut rules as formulated by by Gensen. So you see that Gensen creates something which is called nowadays sequence calculus or sequence system. Why? Because these letters here, they are sequence of formula. Okay, this is a sequence of formulas, this is a sequence of formula. This is one formula. Okay, so what you see in this cut rule is that this formula A, they simply disappear. Okay, disappear. This is why it's called cut, because it's cut in some sense. Well, and what was the important step by Gensen? That he proved this cut elimination theorem, which is one of the most important theorem of modern logic. We can say top 5, something like that. Well, and from this cut elimination theorem, as a corollary of this cut elimination theorem, he proves the consistency of arithmetics, just after the result by Gödel. And of course, it's a relative consistency, but it's a consistency of arithmetics. And Gödel had good contact with the work of Gensen. He spends many years studying the work of Gensen about that, and he made also some proof of consistency based on this idea. But what is, I will not talk about that today, but I want to explain what is a cut elimination theorem and what is important from the philosophical point of view. And you see, if you look at the system of Aristotle syllogistic, all rules of the syllogistic are rules where something is a pure middle term. So they all are a form of cut. Now what Gensen did after, on basis of the work of Hertz, he constructed a system where only the cut appears only in one rule, and there is no cut in the other rules. Okay? And then he proved that it's possible to have exactly the same results using this rule or not. This is why it's called elimination. And this is very surprising. Very surprising because at the end, what Gensen showed is that we don't need this rule. We don't need to cut anything. And so it's completely opposed to Aristotle. So one of the first consequences of the cut elimination theorem by Gensen is what we can call analyticity. Because if you want to prove something, you have a formulas, in mathematics, can we deduce such something like Fermat theorem from the axiom of arithmetics? What the theorem of Gensen is saying is that you don't need to use something outside of these formulas to prove the results. That's why we can call it analytic. Okay, now to finish my talk, because time is gone, I will say about the square of opposition, which also I think is a very interesting topic relating classical modern logic and traditional logic. So here you have the syllogism of Barbara on the right, and on the left the Baroque syllogism, and you can understand the relation between these two syllogisms by the notion of contradiction, which is one of the main notions of contradiction, of opposition in this square of opposition, which was himself not developed by Aristotle, but was based on some idea of Aristotle, especially the distinction between contradiction and contrariety. So Aristotle made this distinction, and after some centuries, Apuleius and Boëtius, they designed this square, which explains the relation between four propositions using this free notion of opposition. Well, there is a discussion to know if it's square of opposition is part of syllogistic and so on. Well, I will not enter in this kind of detail, but what we know is that these people like Apuleius and Boëtius, they made a synthesis of syllogistic with the square of opposition. So it's a theory of reasoning in some sense. And this theory was developed further on in the 20th century by Robert Blanchet with this book, Structure intellectuelle, Essai sur l'organisation systématique des concepts. So I will say a few words about this work, and this will be the end of my talk. So what Blanchet did, so this book is, sometimes it was not so well known. Nowadays people start to study it again. It has not been translated in English, but Blanchet in France is very famous. So what it is? Well, Blanchet, he will present an hexagon, which is a theory which is a continuation of the square of opposition. It's a theory that will explain, that we can use to apply it to the understanding of many concepts. So let me give this example, very famous, which is a deontic hexagon. So with this theory, so in fact, Blanchet started his work because he was interested in deontic logic and he was criticizing von Wright, and this led him to draw this hexagon, which permits to make a distinction between these two notions, what is optional and what is allowed. Sometimes we can say permitted or something like that. And before Blanchet, this distinction was not clear. So and this hexagon also applied to quantifier. The same. Blanchet was able to make a distinction between two quantifiers which were most of the time confused. So what can we say about that? Is that we have a theory, this theory of opposition. So it's a theory about reasoning in a very general way, because we have three notions of opposition, and we will apply this free notion of definition of opposition to develop our reasoning, not only our reasoning in the sense of making a proof, okay, but in the sense of having a better understanding of the distinction, relation between different concepts. So it's a very wide way to understand reasoning. It's not just a formal system, but it's a theory. So, we are organizing this, I will finish with this announcement about World Congress of the Square for Opposition. So we are organizing now the 5th edition in East Island, so everybody is welcome. It's a nice location. I have here a poster. And Serge was to the previous one in the Vatican 2 years ago. Thank you very much.